Ask my instructor 6.2.37. Find the area of the region R bounded by the graphs of F and G in the first quadrant. We're looking for points of intersection, and we can do that either graphically or algebraically. It looks like they both go through the point 0, 0, and a quick check confirms that f of 0 equals g of 0 equals 0. It also looks like the graphs agree when x equals 10, but they do not. To find the second point algebraically, we set f equal to g, and we're going to assume that x is not 0. Since x is not 0, we divide both sides by x. Now divide both sides by 2. And square both sides. Squaring both sides, we get this equation. And solve for x squared. Get x squared by itself on the right-hand side. Do the subtraction and move it over to the left-hand side. Now we're ready to solve for x itself. When you take the square root of both sides, you have to keep in mind it's plus or minus. Recall that we are working in the first quadrant, so we are going to choose just the positive solution. So the functions agree when x equals 1/2 the square root of 399. We are adding rectangles of height f minus g and width dx. The area of each rectangle is f minus g times dx, and the total area can be found by finding this integral, evaluating this integral. We're going to separate the integral into two. The second integral is fairly simple. The first one is not. I'm going to do the first one first. We look under the radical for our first guess on what substitution might work for this integral. So we're going to make a first guess of u equals 100 minus x squared. And then we're just going to play it out, see if it works. If u equals 100 minus x squared, find du. du equals negative 2x dx. And so x dx by itself would be negative 1/2. So in our integral, x times dx will be substituted in for negative 1/2 du. So we're going to trade x dx, we're going to trade that in for negative 1/2 du. And 100 minus x squared, that's going to be traded in for u. What are we going to trade in for the bounds? Well, if you keep in mind that the new bound is 100 minus x squared, then we take the upper bound, we square it, and we subtract that value from 100 to find the new upper bound. Likewise, if the lower bound is 0, then the new lower bound is 100 minus 0 squared. And we have some cleaning up to do. We're going to bring out the negative, we're going to rewrite the power, and we're going to clean up the bounds as well. All right, now I'm going to use this nice little formula that the integral from a to b is the negative of the integral from b to a. And that allows us to make our integral a little bit easier, a little to manage. All right, so now that we've done that, it's time to integrate and evaluate. So what's the antiderivative of u to the 1/2? After you find that, then you evaluate. And evaluating it, I get 1599/8 all over 24. All right, so we completed that part, that first part, and we got 15,998 over 24. We now need to do the second integral to finish up the problem. Fortunately, this part is easy. So what's the antiderivative of x? And then evaluate it, going from 0 to radical 399 over 2. And simplify it, and you get 399 over 8. So put these two results together, and we get that the area between the two functions in the first quadrant is 14,801 over 24. Take care and let me know if you have any questions.